Welcome students. Now today's subtopic is radiation. Under the heading, let us see few definitions regarding that one. In that one, the first one, let us consider we have the any surface, any body seems to be considering the radiation in the form of photon or quanta or packet of energy is allowed to fall on any surface. That time some amount of energy it is transmit, some amount of energy it will reflect. Okay, means whatever may be the energy that is Q which is incident on any surface, some amount of energy reflect, some amount of energy refract or transmit Okay, this is the actual phenomena. We say that depends upon such a factor. We are going to decide the first definition, that is coefficient of absorption. Coefficient of absorption. Here it is B, it is coefficient of absorption. Now this coefficient of absorption, which is denoted by the symbol that is QA. But what is this QA? That is very important. Now as per the definition it is concerned, QA is nothing but, or this QA is the amount of energy absorbed actually. So I need to consider one factor, that is coefficient of absorption, that is A. So coefficient of absorption A is amount of energy absorbed divided by total amount of energy falls on the surface of it. Here QA is the amount of energy which is absorbed and QR is the amount of energy reflected. So this is the coefficient of absorption, this much of amount of energy which is absorbed when Q amount of energy which is falls on the surface of it. So this is a ratio of similar quantity, don't possesses any unit, means no unit, because it is a ratio of similar quantity. Similar to that one, we have coefficient of a reflection. Coefficient of a reflection, which is denoted by the symbol that is R. Okay, here R, that means R depends upon QR. This is the amount of energy reflected when amount of energy, total energy, falls on the surface of it. So R is equal to QR upon Q, the ratio of amount of energy reflected divided by total amount of energy falls on the surface of it. This ratio is known as a coefficient of a reflection, and again it has no unit because it is a ratio of similar quantity, so it doesn't possesses any unit. So we have again number 3, coefficient of transmission or a refraction. Coefficient of transmission. Denoted by the symbol T. Okay, this is the coefficient of transmission. Means here it is just like the Q, we have the QT amount of energy, it is absorbed. So depends upon the same one, that is QT is the factor which is transmitted. Actually this much of energy it is transmitted. So coefficient of transmission is equal to QT upon Q, the ratio of amount of energy transmitted divided by total amount of energy, radiant energy, falls on the surface of it. So again it is a ratio of a similar quantity, so no unit. Okay, that means we got the equation for the A, equation for the R, and equation for the T. Just sake of remembrance, ART, coefficient of absorption, coefficient of reflection, coefficient of transmission. So let us get the relation between these three now. Let us get the relation. A relation between A, R and T. Let us get the relation between these three. See how simple it is. Sir, total amount of energy which is falls on the surface of any material or a substance, in that one some amount of energy reflect, some amount of energy refract or transmit. So total amount of energy is the addition of amount of energy absorbed, okay, that is QA plus QR reflection and QT, that is transmitted. Means this much of means the total amount of radiant energy when it falls on the surface of it, QR amount of energy reflect, QT amount of energy refract. So total amount of energy is absorb plus reflect plus transmit, because here some amount of energy, that is QA amount of energy, it is absorbed by the material. So here it is. Sir, we supposed to get the relation between this A, R and T. For that one I am going to divide equation 1 by Q. If we divide LHS as well as RHS by Q, let us write the equation. Q by Q is equal to, for each value, QA upon Q plus QR upon Q, and we have this QT upon Q. This QQ get cancelled, means only one remain, and here it is A. What is that A? That is coefficient of absorption, which is the ratio of amount of energy absorbed to the total amount of energy incident on it, plus R, that means coefficient of reflection, which is the ratio of amount of energy reflected to the total amount of energy incident on it, plus T, that is coefficient of transmission, that means total amount of energy transmit to the total amount of energy falls on the surface of it. So as we got the relation, that is A plus R plus T is equal to 1. Now, depending upon the radiation, let us know the several factors or definitions or classification regarding the substances, just like the number 1, that is athermalous. Athermalous substances. And diathermalous substances. Second one, that is diathermalous substances. Actually, it depends upon the radiation which are allowed to pass through that one and not allowed to pass through that one. First one is athermalous substances. The substances which does not allow to pass any radiation through that one is known as athermalous substances. Example are wood, water, then we have this copper, Means athermalous substances are those substances which do not allow to pass any radiation to pass through that one, is known as athermalous substances. Examples are the wood, water and copper. And diathermalous substances are those substances, means here it does not allow, here it is in case of athermalous substances, it allow to pass a radiation through that one, is known as diathermalous substances, just like the oxygen. Okay, oxygen. And we have this we say glass. These are the best examples for the diathermalous substances. So depends upon that one. We have the athermalous substances are those substances which does not allow to pass any radiation through that one, is known as athermalous substances. Examples are wood, which does not allow any radiation. It is act like an insulator. Whereas diathermalous substances are those substances which allow to pass a radiation through that one. Examples are oxygen and glass, the best example through which the radiation can easily be passed. So this is all about the substances type. Now we have the perfectly black body. Perfectly black. As we know everyone, during the we say hot season, we are wearing such a clothes which does not absorb the heat. That means we are wearing a white color usually, not the black one. Why? Because black absorbs larger amount of heat as compared to the white one. And that's why we are going to say that perfectly, name itself indicate perfectly black body means total amount of radiant energy which falls on the surface of it is absorbed by such a material or a substance is known as a perfectly black body. A body which absorbs total radiant amount of energy which falls on the surface of it is nothing but a perfectly black body. Sir, is it a possible that there may be a possibility of 100% absorption of total radiant of energy which falls on the surface of it? No. Actually, in nature, example we have, that is lamp black. Which absorbs 98% of radiant energy which falls on the surface of it. But in nature, such a body does not exist. Actually, seems to be it is predicted that black hole absorbs total 100% radiant energy. But here it is just a prediction. So that's why, and it is we say that contradictory to the fact that we are not going to utilize or we are not going to observe any black hole. But in nature, lamp black is always present. So in nature, only the 98% means not 100%, but near to that one, the 98% absorption it will take place, which falls on the surface of it. So depends upon that one. One scientist who has get that body or created that body known as a Fairy's black body. Fairy's black body. Let us know about the Fairy's black body. Fairy's black body. Now certainly see the diagram. In the diagram, Fairy has created the black body absorption completely 100%. He has proved that, or artificially he has created perfectly black body, taking a metal sphere which is a hollow one. Total it is 2 walled. Outer wall is silver, so that whatever may be the radiation which is falls on the surface of it, it is get reflected, which does not affect the inner part of that one. And in between the two, it means two bodies or two spheres, inner sphere and outer sphere. Outer is silvered, inner is coated with a lampblack, and one aperture or just one hole, small hole or aperture, it is taken at the side. See, it is through which the radiation is allowed to pass, and totally inner wall it is coated with a lampblack, and total lampblack it is coated inner sidely completely, including the conical projection just in front of the hole. See why this projection is present, because as amount of a radiant amount of energy which passes through that small aperture, it will again reflect back with the same hole, so as to avoid that in multiple reflection, and each time the 98% of energy, radiant amount of energy which is falls on the surface of it, it is absorbed in multiple reflection. Total radiant amount of energy it is absorbed. Let us see. Outer wall it is silvered, inner wall it is blackened with the lampblack. It is totally coated with the lampblack. In front of projection, we say that in front of hole we have the conical projection, so that internal reflection in multiple reflection it will take place. And total part in between the two spheres, inner part it is evacuated. No air is present in between that one, so as to conduct any radiation through that. And as the radiation enters inside, it will struck to the, we say, conical projection, and in each time it absorbs 98% of radiant amount of energy which falls on the surface of it. Again, out of that remaining 2%, again 98%, again in multiple reflection 98%, and total energy it is absorbed internally, and no radiations comes out from that. Hence, this is the, we say that, Fairy's black body, which absorbs total radiant amount of energy which falls on the surface of it, artificially created by the scientist, that is Fairy, and that's why it is known as a Fairy's black body. So this diagram is very important as per the board exam it is concerned. Each and every time this may be asked in exam. At least 3 or 4 labelings are compulsory, and you will have to show the evacuation, lampblack coating inside, conical projection, and aperture. These are the most important labeling as per the examination point of view. Thank you.